If I was to ask you what is the definition of parallel, you probably would just say lines that never intersect. It's not a bad definition, but it's not complete. I guess I want you to notice first what I've provided as a definition. It is coplanar lines that do not intersect. Now that may sound extra to you or not important. It's very important. So in the diagram you can see here, there are two parallel lines that you can see, CD and AE. Those are parallel. There are other ones in the group. For instance, we could say that the top edges here and here would be parallel. We could say that these edges here and here would be parallel. Watch the next one. You won't believe me, but it's true. It would also be fair to say that this one in this upper left corner and this one would be. Those will never meet, and they will run parallel to each other. The plane that they sit in is kind of like a diagonal plane through there. It's there, it exists, it would be valid. Now, I still haven't quite told you why I have to include, or we need to include, the word coplanar in there. That's because if I did this line here, maybe let's do it darker, this line, and this line, those lines, if you're looking at a real box, will never intersect. Now, it kind of looks like they will down here. That's not true, though. Think about it. The front edge of the box going up and down, and the bottom right edge of the box going this way, these would never touch each other in any space. Now, in theory, those are parallel if you just said lines that never intersect, but we need to fix it so they have to be in the same plane. Those lines actually have probably a new term for you called skew lines. Those are lines that never intersect but aren't in the same plane. This one running up and down is not in the same plane as the one going back and forth. They will never physically intersect. Let's find some other skew lines. How about if I did this back one here and this one here? Those lines in real 3D space would never intersect, and so on. So skew lines are non-coplanar lines that never intersect, right? Non-coplanar lines. So we're just cleaning up the definition a bit. Let's take a look at our diagram here. Let's look at AB right here compared to CD back here. Now those aren't running in a parallel manner, but they will never meet. And so for me, our response to that would be those are skew. In the next case, EF, let's take a look at EF. EF is here, and DG is here. These, of course, are parallel, aren't they? They're going the same direction, and they are exactly parallel. How about AF here and EF here? Now, those guys actually physically intersect, don't they? And so they intersect, in this case, perpendicularly. The final one, let's take a look. CG, kind of interesting on the diagonal here. And AH down here at the bottom. Those guys will never intersect, but you know what they are. They are skew lines. So let's take a look at parallel and perpendicular and their relationships to slope. First, we see that if two lines are parallel, their slopes will be equal. I think that makes sense to us. If I have a line here and another line here, and they are parallel to each other, what it's saying is whatever this slope is, whatever this is, this slope will be the same. And that's why they will never intersect in the same plane. In a similar manner, perpendicular slopes are negative reciprocals. So if you have one line going this way, a perpendicular one has to go the other way, doesn't it, to form that intersection. They will always be negative reciprocals of each other. Now, what does that mean? Let's say this guy was 1/2. This guy would be negative 2 over 1. They are negative reciprocals of each other. And what that ultimately means is if you were to multiply those two together, you would get the answer of negative 1. Let's pursue that a little bit more. So if I had a slope of 3, its negative reciprocal would be 1/3. If I had a slope of 2/3, the negative reciprocal would be negative 3/2. If I had negative 1/4 is my slope, then of course 4 would be my value of my perpendicular slope. And when you multiply these guys together, they always give you a value of negative 1. Keep this in mind. I'll show you a tricky one too. How about 1 and its negative reciprocal would be negative 1, because that does work out, and it's just a little bit of a unique case. In a question like this, they're interested to know if these are parallel lines or perpendicular. I can see here my slope here of negative 1. I can't see it in the second case, so why don't we take this guy, divide everything by negative 3, and I'll go slow here so you can see what's happening. And I get negative 1x minus 3. This is a negative 1. The original one was a negative 1. These are parallel to each other. Let's try the next one here. Again, I'm aware of the slope of negative 3. And actually, I can find this slope as well. So the first slope was a negative 3. The second slope reduced is 1/3. These are perpendicular. In this question, neither slopes are provided, so let's do a little work here. I'm going to move the 3x over in the first example, divide everything by 5, and I get this answer. Now let's do this guy here. I'm going to move the 5x to the other side. And I'm going to divide everything by 3. And I get negative 5/3 x plus 5. Let's take a quick look at our relationships. I get negative 3/5, and I get negative 5/3. Those are reciprocals, but they are not negative reciprocals. So these aren't parallel, they're not perpendicular, they are just simply intersecting lines. In the second example, I do already have one slope, so let's go find the other slope. Let's move the x to the other side. It becomes negative, and there I have this slope. So one slope is 1, the other one is negative 1. Those are negative reciprocals. This is a perpendicular relationship. So the key here is, now that we know parallel and perpendicular, it says knowing the slope relationship of parallel and perpendicular lines helps us to determine the equations of these types of lines easily. Usually, to generate the equation of a line, we need two things, the slope and a point. Knowing the relationship is either parallel or perpendicular simply provides us information about slope. So if I say to you, I want to make a parallel line, what I'm really telling you is I want slopes that are equal. And if I tell you I want a perpendicular line environment, I'm telling you I want slope relationships that are negative reciprocals of each other. So let's try two of those. This question says, what is the equation of a parallel line to this one? And our parallel line must go through here. Well, this sounds fairly complex, but actually all it's saying is give me a line that's parallel to this one. Well, that means our slope is going to be -7 if we're going to be parallel to this one. And we need to go through this point. So this is review of an equation given a point and a slope. And so the way we handled this before is we went to slope-intercept form. We knew the y value, we knew m, we knew the x value, we did not know b. We've solved for B, here it is. And now we can say, oh, a line that would be parallel to that would have this slope, and it would go through this point here, or this value here to go through this point. We could indeed plug that in, and we could, if we put in a 3 here, and then we put in a 1 here, guess what happens? Everything balances, 3 equals 3. So that is a line that actually does do exactly what we want it to do. In this case, we're being asked about a perpendicular line to this one right here. Again, this is a clue about slope. Our slope then will become a -4 slope because that's the negative reciprocal of 1/4. And we're going to go through the point -12 and 4. So we can now solve for the only thing we don't know to get an equation in slope-intercept form, which is B. Let's put in the 4 in the position for y. Our slope is -4. Our x is -12. And when we move things over to the other side, we get a total of -44. So our equation would be y equals -4x minus 44. Again, we could check that out. If we put in our y value, that would be a 4 here. And if we did -4 times -12 minus 44, that's 4 equals, what do we get there? We get 48 minus 44. And yes, 4 equals 4. So this indeed is our equation of a line that is perpendicular to this one right here. And we'll go through this point here.